Welcome to NX for Manufacturing Tech Tips. Today's tech tip is titled, How to Make the Best Use of CAD for NC Programming. Demonstration will last approximately 20 minutes and we'll stay on the line and open up the chat window for Q&A. With that, I'll turn the session over to Brian Dreibelbus. Welcome, Brian. Let's get started.
Thanks, Derek. All right, so as Derek commented, I work in the Americas Zone channel, and we see lots of customers, lots of prospects, etc. So pretty much just as a review is, you know, there's a lot of noise, a lot of chatter going on about this CAM software industry, and there's lots of features, right? So we say it's kind of overflowing with capabilities. And a lot of times we always focus on the toolpath, and our competitors the same way. They seem to focus on the toolpath. Here's how we cut it. Now, while toolpath is very important, one of our other primary concerns is how we can really impact the operations up front, because everything usually requires some kind of geometry prep, setup, etc. And these things really lead to important time savings and capability inside the overall workflow in the CAM system. So some of those things are like importing the geometry, being able to view and measure all this popular CAD system data that comes in. This seems to be a troubled area. And then the ability to painlessly edit and repair that data, right? Because different CAD systems, different data, different designers. At times there needs to be, the model needs to be prepared for a manufacturing model, right? So that we all know those are issues. Designers sometimes design things that become very difficult to machine or manufacture, are very costly. So the ability to make changes to that data that fit for a manufacturing process becomes important. And again, optimize it for your tooling and your manufacturing process. Additionally, is you can use the same design data for the in-process models, maybe for this, the stocks, the blanks, work around fixturing for the part. This also is part of the CAM environment for avoidance and collision zones, right? You want to know about where those are on the part and in the programming, regardless of the CAM system you use, just as preparing that data. And then, of course, you want to create all your manufacturing setup assemblies, right? Because you need drawings and those kind of things to go out for your setup guys to set up the machine tools, etc., that the fixtures and parts in the right place where the CAM programmer expected it to be, right? And then, obviously, we want everything to be scalable. We want it integrated, spend the best amount of time utilization. So if you need to make an ECO, ECN, or design change to go on with it, or even just a programming change on the part because of the tooling changes, that everything is integrated. You can make one change one where and it propagates throughout the different models. All right, so let's take a, with all that said, I'll give you a little bit of a peek in here. This is probably easier to see than inside the software. It's a big list of the import capabilities of CAD, so you can see there's all kinds of things from even FEA type models. You may get that to come again. We can read that kind of data and use all of these things as CAD models, right? So these are just different file formats. So again, you know, we can measure data on the design data. We may need to make some setup drawings. You can build setup assemblies, and even take the same design data like that, and we kind of defeature and refeature the part into, maybe you need it as a stock or blank, or maybe you needed this as a forging or casting, right, to come if you didn't get that data and you're expecting a forging die or something from that. All right, with that, we'll kind of move on. Part of this key technology for us inside of all of our CAD products, and specifically inside of the NX CAM products, is synchronous modeling or synchronous technology. With that, gives us the ability to take all of this imported data and make changes to that data. We can add parameters to, quote, dumb solid models, right? Featureless solid models. We can recognize those things as features or conditions or areas. As you see in a little model here, we can find the post and the rib. We could dimension to that and dimensionally drive that particular feature, right? Not only just drag it on the screen and turn things on and off, because we can literally redimension that or reparameterize it back into an intelligent solid model meant for a manufacturing process. In other words, get this optimized correctly to be a manufacturing model from a design model. And these are the kind of things, just in a high level of things, synchronous technology it is. You can move face, you can add draft, you can resize the blends, you know, you can patch and close up openings, you can, you know, extend surfaces. As we say, is ideal visualize the geometry and optimize that geometry, right? So your surface areas and things are good for your smooth flow of tool paths. They're not all full of little sliver surfaces and choppiness. So those are the kind of things that we take a look at inside of synchronous technology. With that, all of the data prep, what it is you can import different CAD models, of course, and then you can build some stock models or blanks, or again, you could open those up and make changes to them. So we're going to go through this little aerospace wishbone type part, show you a way here if we wanted to make a little billet and a blank for it, and cover all those areas we did there, some modifications to the part, some optimization to it, build that, create setup assemblies, the drawings, etc. So we'll go ahead and take a peek at doing that here in just 1 minute. So the next thing I just would like to show you from a larger state here is, again, with synchronous technology, we'll take a look at this. And at times the blend radiuses come in, and it may be a deep pocket. And depending on that, as we've seen, and typically this was a real customer type part, there were different blends all over the place in the pockets. And when we go back and we look at the drawing for this part, and there were tolerances like ±5 on some of these blends, we could redefine those blends as being, common tool nose radius, right? So we could go and find, standard 8, 16, 32nd, whatever our ball nose radius to match that. So we don't have the scallop and surface repair, polishing, etc., that would have to go into these models. And so that's what we really say is about optimizing them for a design standpoint. So with that, I'm going to go back and we'll hop right in the product here. Take a look at this in NX. There we go. So we should all be here in NX at this point in time. So show you how you would start approaching this from the beginning. So we would go in and say maybe we want to create a new part for this, right? So we're going to bring in some data, but we're going to actually create this inside of, we would say, an NX type environment. So we can maybe call this as a master model, which would maybe contain all this data. So there we would just say we want to create a part with this. And then we would go here and just tell it we want to bring some data in, right? So these are different applications to go along with that. So we'd say file, right? And we want to import something. And again, here was the list, right? So you can say we want to bring in a CATIA file. We know that was a CATIA file. There's standard Windows type browse things, and we can just, pick the parts and bring them in, right? So that'll just open the part up. There we have our part come back in here like that. And so here we can start maybe doing a few measurement operations. But sometimes at first what I like to do is, this is where the part may have been created, or they said was their 0 point on the part. So if we wanted to make and set this to a different location, if we wanted to work on it, it just sets a default location for this. So again, you can grab a hold of the handles, right? So we can change this. You can flip sides, etc. We'll place it and we'll snap it right there into 0. So this just really says is, if I want to align the part somewhere on the screen, I can just literally press that, and that becomes like my default work plane or 0 point. So again, measurement type of things that go in here is, if we wanted to take a look at what these diameters are on a part, we can go ahead and just select those particular features, right? We find out what those diameters are. Sometimes people use this in pre-planning for their tooling list that may go back out to make sure they have tools, reams, etc. in the shop. So sometimes we see people use this just from the estimator, and the manufacturing engineer goes into NX in a product we call like Foundation, that allows them to open this data, do everything we've done in here, and make changes and take a look at this geometry. So they could do some measurements. Of course, there's a measurement tools where you can ask for, a start point. I can have a ruler and ask for an end point, etc., like that, and I can measure different values. So there's a whole host of measurement tools you can see in here. You can measure angles, radiuses, diameters, etc. So those are just some simple measurement type operations. So if we were going to get this part ready, maybe we want to start the fixturing side of it, so we know this is, let those people get to work at the same time while we're working on maybe cleaning up the model to that. You could, start segmenting this work out a little bit. So I'll just show you a little bit if you wanted to define maybe a stock model or a blank is, right? We'll just create this just as a little sketch that comes in here, so you get to take a peek at how these things work. And of course, you can just grab and drag geometries, and by using setting that 0 point on the part, that just becomes like a default location where our dimensions would attach to. Again, it could have been set as a corner of the part or anywhere you would like. And then from here, you can adjust some of these dimensions. Maybe if I needed an area on the bottom of the part there for clamping, we'll click a little clamping cutout. Again, you can drive it by dimensions. I can grab a hold of the geometry, and I can just drag it. I can redefine it if we want with that part, right? So I can just pull it down and say, well, it's close to 12 inches. We should make it 12 inches, right? So we were talking maybe about a saw cut type operation. Same thing maybe with our width of the part. Maybe we can make him a little bit smaller, and we can adjust our centering right and left from there. So this would be, again, maybe we'll make this number 4 inches. Maybe some people like that as more uniform numbers, and this would give us a start for a blank preparation, right? So with this, we would maybe go ahead and create what that volume is that we would use for our stock boundaries, for working on our part in here. And so we're going to kind of use that in the center, and we'll work on both sides of this. Right? And so we'll go in here and tell it that this is the geometry, right, which is this particular guy here. So there he is. I'll just bring him out here a little bit for you. You could snap him again to the side, take a look at that, and again, you can grab a hold of these as handles. You can drag it. You can enter a value, right? You could maybe create dimensions to the side, etc. So there we can take a look at that and then say we're just going to create this as a stock, or blank piece of material, if you would, for that. So here, well, maybe if you want to change its color, translucency kind of thing, so we can see what's going on in the part, we can do something like this, right? You can turn your sketches off. So there you would have just the basic containment you would for a block. Maybe we need an area to hold it in the bottom. So I would say this, maybe we'd put a little clamping release on the bottom. And again, you could just use some very basic CAD type tools here. Maybe I'll move up 2 inches on my part, something like this. And we'll just go ahead and pick this bottom surface. We want to flip it the other direction. We'll move up there some distance like that. Maybe I want to offset that, right? So this will just actually remove that material in there. So we'll say we want to take it away from that, right? So that would be one way to just generate a simple clamping relief maybe on your stock. Instead of using Mighty Bites, we can use regular clamps or something on our fixture. So just a relative idea of how something like that would work. From here, again, like I said, the idea was to get this ready for the setup guys, and then we'll go back and make some more modifications to the part. They may want to add this to their setup, have a library of machines available to do something like this. So with this, these are the models in a stock. We would say is we want to create a setup for this, and this setup really is indicative of saying this is the part, the model in the stock, but this is a reference of it to create your CAM programming, right? So it's really going to be referencing that model and that stock. And then if we go back into this and say, let's take a look, we're going to add a machine to our assembly. Basically, you could do this by assemblies, but this is just a feature inside of NX CAM that would allow us to go ahead and add these as machine tools. Or maybe we will. Here, where did we go? Come right back. There we go. Let's say edit. Lost a window there for a second. So we're going to look for mills, and of course the whole library. These are our, you could say, out-of-the-box type examples, right? So there's different type of mills and controls, right, for output. So we'll say this would be a 5-axis. We'll say it's a Fanuc type machine. And then we would want to place this. So a way to help load this in your standard load locations on the machine. You may tell it what part you want to use. We're going to use that entire model. And instead, we're going to do a thing we call a part mount junction. Say, look, we mount our parts here. If you have the machine set up with a vise, it always mounts and drops into there. So it can help you save that time in producing that. So let's go in here and just attach this guy. Maybe this is your, our corner, we'll say, for the bottom of our fixture. We maybe want to center that in the middle of the part. Again, there's all kinds of options here of how to locate those. So let's go in here and just say between these 2 points, right in the center. So we'll find this location. We'll pick that location. So there it'll just move our handle for the part, and it drops it onto the machine tool, creates all your tool pockets. So there would be what you would use for just a representation of the machine tool. So we'll say OK. This does build this as an assembly for you right away, which isn't nothing new in the CAD arena, but there we simply would turn off the components of the machine that we wouldn't need, right? So we want the rotary table. We don't need the rest of it. So with that, we could go in and maybe build some assembly on our part, right? So we need add some clamps to this. Again, you can let this window open here. I'll just resize them a little bit smaller for us. Same with their synchronous tools here for a second. We'll just let those there. We'll come back to those in a minute. But if I wanted to add a component, it's literally they go over here and just say, I want to add a component. You can browse out onto your folders or systems. In this case, we have device. You can find all your different devices or fixtures. There's a clamp that we would want to be using for this, and then the next thing we want to do with this clamp is go ahead and mate it. So it says if that's a mating face that goes in there, where's his corresponding? We want him to attach there. Then that face, where do we want him to attach? We want him to attach over here, right? So there we have him mounted. Additional type of assembly things would say is we want to keep everything not moving on the table, so that's where we may have liked it, so we say we keep him fixed. And then maybe we want to center our clamp up right onto a T-slot, right? So you may want to use something like this and say if I want to center this, I could pick both edges of those, the sides of the clamp or the inside of the clamp, and then I could pick, which T-slot I want this to go into, right? So you could just drop this in there. And so then those guys are all constrained, and he, matches up onto your T-slot at that position. Again, you could do the same thing. You can add another clamp. I'm going to show you a couple different options in here to do that. So again, you could add them this way, or we can copy them directly. But if you haven't seen how that worked, it's nice. It comes up. It finds that as a clamp. We define those as an area. And again, you can just select those particular areas like that without really having too much thought to do it, is because you can define this clamp when it comes in, that these are the clamping areas, the constraint areas that we want to use with the part. And then again, you would pick, you want to center that. Again, we remember the last commands you use, so we're not hunting for commands. Again, it just keeps following that sequence, which lets you speed through, you could say, these operations, right? So it's not so much a learning environment going on. And we want to move this guy out here to this NT slot. So we'll let him find the center location for those two. So that would be a quick way you could get those two clamps on. I'll show you some more little things you can do in assembly, which is nice. It helps you. You can just pick parts at any time. We can say we want to copy that. Right, so I can just copy them over in here, and then I can literally just paste them right back in. So now I have another clamp. If I want to move that clamp, right, I can go ahead and tell it I want to move him, right? So I can pick we want to slide him. I put him in the wrong location. So let's just go back and put him up here, right? So we're going to say, boom, I'm going to put him over here. So there's my clamp. Depending on the hierarchy of who you are inside of the assembly, where you want those controlled, if they belong to the machine tool or if they belong to the setup. And I want them to belong to the setup. So again, you can just drop and drag those things. Now when I say move him, right, I can just grab a hold of him. I can just pivot him off there. We'll say at 90 degrees. If I want, I can drag him somewhere else. And I can go back and then do the same kind of features if I say I want to constrain him to the fixture. So if I make changes, all of this kind of stuff updates. With that, I would do this thing, we call it touch align, right? So I would just go back in and I can touch my two mating surfaces. I want this guy to mate with that face, and then I would want the nose of my clamp, this guy right here, to go in and we'll say mate with that face. Okay, so at that point there we have those two. You could drag him into position. We could use a constraint base with this. We could do the same thing with that and say I want to dynamically go ahead and move this clamp, so I can just pick him and drag him on the screen for us, right? Or we can go back in and you can add dimensional constraints with this. So I may want to say I want to do this as a distance. So I could pick, this edge. I could pick this face over here, give it a distance here. I'll say -2 inches. Maybe I'll go back and say I want to make this -1 inch, right? So he comes in there. So that way he's on our corner. Another way you can add components, so if they're all in that place, you wanted 2 or 3 of those, we can go into here with our assembly components and we say we call them an array. So we just want to use maybe that particular component. And again, how do we want to locate those components? So I'll just tell it that's my clamp name, and I'm going to pick along that direction. How many do I want? 1 or 2? Maybe want to offset these guys 6 inches or every 6.5 inches or something like this. I can go back in and then place my clamp. So then I would have my second clamp, it's just a copy, so we could change the number of those clamps. And additionally, if we want the other sides to those clamps, then I can go back in here and just tell it that, again, I'll use an assembly array like this. And I'll say we want to create, I'm going to pick all of our clamps here. We'll give this guy a different name. And this time we're going to say he's circular. And we're going to pick this edge or face. Oops, and in this case here we want to say we want 2 of those at 180 degrees. And there we have all of our clamps and our clamp position on our part. So at that point, we would, you could have that clamp assemblies fully up and working. From here, I'm going to move over into drafting for a second. So if we want to make a drawing of this guy, so we say we want to move into our drafting. So we'll say start. We want to go over to drafting. So again, you could pick your size of paper. We can use templates, etc. Go ahead and place that. It's just telling us that I don't have the template shown, the drawing borders, if you would. So then we say we're going to do our next operations. Right? So we're going to pick our part, say that's the view we're going to base our other views off of. Again, you can change those, and there we can size and scale those dynamically, I guess you could say, onto the sheet if you wish. And then we produce our drawing. So we get, preset those as hidden lines, etc. We go back in, do a little bit of dimensioning on each one of these. Again, we could use the assembly dimensions also. So we can go back and maybe want to place just some basic dimensions on the stock size from this side. Maybe we want to make a dimension location, saying we're going to where he's located, right, from this edge. You may want to dimension your clamps, right? So we can again pick these dimensions and continue on with your dimension changes here. So let's go back here and say we want that as a vertical dimension between here and here. So we'll snap those. Maybe we want to go over here, add this one, etc. And you can continue on, around your part, your different views, and create all of your dimensions. So here we maybe want to create this dimension, your overall height of your stock and your fixture. Again, anywhere that you would think you want to need dimensions, we could change this into infer just enough dimensions for the setup guys and make sure they have the part set up on the table at the right locations, etc. So that would be just a quick way to do that. If you wanted the border turned on, we'll just go there just to make it pretty here for a second, like this. And we'll go down here and just flip the border on there for a second. There he is. Turn him on. And there you go. So that would be a quick way of starting on that job. You may be able to set this off. They could start off making the stock and the blank for the part, if you would, before they were finish the prep on the model part. So that would only take a few minutes to do that. So from here you would go back in and we could make continued changes onto this. We can go ahead and just turn all that back off. We'll just go back to our model here at this point in time, and we could make some changes to the actual part geometry. I'll show you a little bit about refining those areas, like maybe some dimensional changes onto the part. So there we'll use a little bit of the synchronous modeling tool. So we'll take a look at this over here. So one of the first ones I'd like to show you is just maybe you would go back and you want to change some of those hole diameters, depending if they were done as a design diameters and not necessarily indicative of the manufacturing diameters. We can go back in here and tell it that we would want to make a modification to that. So there's things here we have like move a face, offset a face, right? So we can make changes that way. You can delete them. We can make a dimensional change to them. So say if this was a radial dimension, on a part, we can pick that location and make a change to those. In this case here, we can say we want to resize blends on our part. These would be, just different operations that we could add to this. I'm going to go up and dock this menu up on the top here just for a second. There we go. If we wanted to add maybe a few more options to show you other things that are also inside of here that we can add or customize your menu if you would. So these are other things that are available so that you could add to your toolbars just to show you that there's more capabilities inside of synchronous modeling than maybe what I'm showing you today with that. So if we go back in here and say if we're looking at resizing a blend on a face, I can go back in and take a look at this blend. There's some other features on the part. Oops, let me go back and actually get the part. There we go. Let's go back here and say start modeling. Sorry. Make sure we're in the right part. Let's go ahead and make sure we have our synchronous tools here. And we'll go back in here and tell it that we want to resize a blend. Oops, I still don't have my part out here. Hang on here a second. There he is, making the work part. So if I select those faces, we know by the content we're selecting it, like it says look for a connected blend face or look for all blends in a face. So those would be the blend areas we would want to change on our part. And depending on the topology of the part, you can make changes, or we're going to give you some feedback on there saying is what other areas may be affected with that, right? So there we could say we want to make them smaller. So now we have a 50 thousandths blend radius on the part. And again, you could make these changes to any size. You can maybe want to drive and see how large a blend radius or something like this would be. We can go ahead and make those kind of changes with this also, right? So there, if we go back, we'll say resize this blend again. We can select that. It finds all those blend radiuses. Maybe we want to make this an 1/8 inch blend, right? You can go ahead and do that. So it'll show you the preview for him, right? Maybe you want to make him a little bit bigger. You could go in here. You'll see how big it'll go. Maybe we'll make him a 250. So just to give you an idea that shows that these are the kind of size changes and things you may want to optimize for your part. Maybe you're going to make him 1/875, right? So you're going to do something like this with the part. So that shows you one area where you could optimize that. Again, you may want to look at some more blend faces in here on the part. This seems to typically be some areas we get a lot of response on it saying, well, we got that tiny blend raises, so the cost of manufacture was more expensive. They may go and change them just for the manufacturing model for improving the efficiency of the tool path like that. So if we're going in here and doing a waterline machining operation on that, we may want to make that a small blend radius or a larger blend radius, right, that matches the tool nose radius. And then on our final machine path, we would change this, to the actual finish machine size. So again, you can maybe want to match these guys. You could do something like this with the part, and you can make some blend radius changes with that. So again, those changes are certainly indicative because as part of our model and constraint, we're just making some models there. Everything else updates with that. If we wanted to go in and make some additional changes to the part, maybe from a stock type perspective, you can do things as little as saying as you want to pull a face, right? So I can select a face, I could grab a hold of that face, and it says, well, look, if you want to try to make an attempt at this, is there some blend radiuses that would be consumed? So other things at times people would do is go in and literally take a look at some of these areas on here and say maybe I would remove those two faces, the little tangent faces that are going in there. They would have been consumed with that. So again, you could use maybe pull a face. We could take a look at doing a pull face on this operation. Of course, this guy over here maybe would have a little bit of some issues with that, right? So it says, create a smaller one, or there's a face of an intersection. So we try and give you some feedback of what's going on with the part. Topologically, in other words, if you were going to make this as a casting model for that. Especially a little bit if we wanted to offset into this area first, how the offset would work, and I'll show you a little bit more of some blend. So when you do work on these areas, they do sometimes take a little bit of analysis time, if you would, to try and understand what's going on with the topology and what you would be able to make a change with the least amount of effort or work, we'll say, on the part. So we'll take a look at that. So there, in this case, we could say we want to move it in, we want to move it out. This would create our stock offset. So if you wanted to create an additional, just in that area, right, so you could add that, you could thicken this guy up. these are all remembered commands. So if we look over into history, you can suppress these, or you could turn them off and go back to the original model on the part, right? So you can go back and make all those resize blend changes occurred on the part, right? So there was our final last resize blend. So this guy's back here to our 1/8 inch, right? So you can go back and turn those on and off, I guess you could say at will, or where they may be relevant to the actual overall process. If I wanted to make change to that offset region on the part, again, I can maybe grab a hold of that. I could pull that area, right? So, tell them now we have a 1/4 inch offset, you know, to our overall part. And again, we can continue working on that part and at times adding features or defeaturing it. Like the holes, for instance, if we wanted to make this as the casting stock for this part rather than do it from a billet, we would do things like this, is go into the part and you would literally select these areas here, and we want to go back and remove particular part areas, right? So we say here, if you wanted to, you know, create these, we just delete these, and it refeatures the part basically back into a solid, just like these features. And they're not patches on the hole. It actually is completely healed, so you don't have the surface scarring going on that you may see. You may see a lot of other competitive products go in and say, well, we can patch and close all those holes up, but then you have these surface boundaries as the toolpath at time takes longer to calculate while it tries to figure out what to do with those scarred areas. I'll show you a little bit of defeaturing here on a hole location too. So the same thing we would do with our holes. We would remove those areas of the holes. If I go in and take a look at this for blend faces, I can change my selection intent up here, which says a single face, and I could look at this and say connected blend faces. So now it's going to look for those from an intelligence standpoint and say those are all blends. So again, a single pick takes less time to completely do that. If I say is, you know, a partial blend set back, so if we needed to just set it back from a corner, I could pick that, or I can just go ahead and delete all of those blends in that area. Here, this one may affect where the cutout was on the part, so again, we may remove that and add that blend back in later at a smaller size of what would be indicative of the stock size. And that's an example of what we call as a partial blend. So if I go back and just delete this guy here, oops, second here. We're going to go back onto here. And instead of all the connected ones, just a single face. That's really what this error is complaining about here. So let me just repick him again here. We'll say delete a face. Make sure we're here on a single face when we go to pick him. And by picking this with that partial step back, you can see what you're doing on each step, you know, right, of what that feature was, right, the intelligence, the way we're kind of understanding the topology of the part as it goes through there. Again, there's a little blend corner on the bottom. You may want to remove him, so you can really, we can take a look at the overall, oops, again we say is single face. And we're just going to go ahead and delete this guy. Now we'll go back into this face here, and you may want to go in and we'll just remove all of this area inside the part. So in other words, it'll create this back effectively as the, maybe as a casting would have looked like for this part. And again, it's just going to make this back as a solid, right? So it's not a series of scarred surfaces. I'll show you this other one up here real quick and show you how to do an offset to both of those guys. Again, we use a lot of this delete face or resize faces on these. In this case here, we may just want to pick both of those separately. Right? So, and again, this is remembering the history of what you're doing with that. So if you made an update to the imported model that comes in, there was an ECO or ECM, we can replay all of that history. Will come back. So if there was just a dimensional change, or you may want to use synchronous modeling just to actually make that ECO or ECN change. Maybe it was a dimensional change, something like this, right? You could use those kind of features with that here. So I'll be down here just in a second with that. Maybe we'll do the same thing as we'll remove these blend features down on here. And here again, you could have used all of your connected blend face, type command. It'll pick all of those at once and save you on the picking. Again, you could use offset things on a region, and these are all selection intent. It says use the face finder or select it by an offset. It would understand symmetry of the part, or it could select things that are of equal radius. So again, these are all performance enhancement type operations or commands inside the software to help speed up this time. So if we pick these particular faces, they're able to set maybe a 50 thousandths radius with that, right? So there we can say he's a little bit smaller. There he's going to be a little bit taller. Maybe make that a little bit bigger for y'all can see that. So there he's much bigger, right? And if I flip his side, there he gets even gianter, right? So you can set those different values for that. So there we just took that same stock model, increased his size a little bit for that blank. From there, you could go back in and you could, reblend this again if that had, particular blend radiuses on here. Of course, this is just your standard, kind of blend features. You may want to create that back as the actual, casting would be. So this would give you some options to do that on the part, right? So there's our blend. Maybe we want to remove this little corner over here first. We'll blend our sharp edge off. Or the same with this edge on the offset. Again, we would use offset through here. So again, we'll pick our little edge blend. There you can see creates a little bit of a sliver surface. So what would you do with that? Again, it's just give you this feedback. We could go back into this one. We could resize the blends, or we could remove the blends, right? We can just remove those guys, go back in there, and then we can set the appropriate blend sizes, that would represent that for our casting or our edge blends on here. So maybe we would do these first on the edges there. Then we would go back and create this guy. He'd wrap around here on our corners, perhaps, something like this, right? And then you can go back and continue blending, all your sharp edges off or whatever you like to do. So with that, that's more or less, I think, we'd be ready for if you had any questions. I guess we should go back and show you that we have these updates back in our model. Right, so if we go back into our setup assembly here, make this guy our model. Go back in here, and we'll go back into manufacturing. So there you can see is our model was set up in there. We'll go in here and we'll turn on our stock models. And if we wanted to see that guy here again, a little translucent, we can just, again, change his translucency, or you can make him look like a nice gray steel or whatever you would like to do with that particular part. So there you go, guys. So if you have any questions, I guess I'd open it up for that at this time, Derek.
All right. Well, thanks, Brian. That's an awful lot of CAD for NC programming in 20 minutes.
Yeah, it's
you all came away with some good ideas, and I especially appreciate the way you approach all these edits and modeling tasks from the perspective of the NC users.
Well, thank you.
I want to encourage everyone to join us in 2 weeks for our next session. That'll be all about making holes in NX CAD. And as always, the conversation will continue at our discussion forum, where we'll post these videos and follow-up questions, and you can pursue with additional topics and questions from there.